Your phone's battery hits 2% and panic sets in. You dig through your bag, pull out that trusty power bank, and breathe a sigh of relief. It's just a simple plastic brick, right? Wrong. Inside that little gadget is a tightly packed, precisely engineered powerhouse, the result of a manufacturing process that combines the finesse of a watchmaker with the heavy-duty efficiency of an auto plant. From sourcing high-grade battery cells to running safety tests that would make an airplane jealous, every step is designed to deliver reliable power on demand. Today, we're stepping inside the factory to watch massive battery packs come to life. And trust me, there's a lot more going on than you think. Every power bank begins with its heart, the battery cells. Most factories use lithium-ion or lithium polymer cells, prized for their high energy density, long lifespan, and lightweight build. But not all cells are created equal. Top manufacturers source from trusted suppliers, often the same ones that provide cells for laptops and electric vehicles. When shipments arrive, it's not just a matter of unloading boxes. Each batch is subjected to rigorous incoming inspections. Workers in clean uniforms unpack the cells under bright overhead lighting, scanning each one for scratches, dents, or signs of swelling. Any imperfection could be a ticking time bomb in a finished power bank. Then comes the technical check. Test benches hum quietly as cells are slotted into holders and connected to diagnostic equipment. Voltage levels are measured to the decimal. Internal resistance is checked for efficiency, and capacity tests simulate a mini charging cycle to verify the cell's true potential. Only cells that meet strict standards make it past this point. Those that don't are set aside for safe disposal or recycling. By the time a cell leaves the inspection table, it's been handled with the same caution you'd expect for a component destined for a spacecraft. These approved cells will form the core of the power bank, quite literally storing the energy you'll later rely on in that moment of 2% panic. Once the battery cells pass inspection, they move to the preparation area where they'll be arranged into the exact configuration needed for each power bank model. For smaller units, a single cell might be enough, but for high-capacity models, multiple cells are joined together into a pack. Workers line them up on long assembly tables, each cell positioned with careful precision so the terminals face the correct direction. This isn't just about neatness. One wrong orientation could cause a short circuit or complete failure. The connections between cells are made using thin nickel strips, spot welded in place by specialized machines. Each weld sends a tiny, controlled burst of energy into the metal, fusing it to the cell terminal with a quick, satisfying spark. The sound is faint but steady, a rhythmic zap, zap, zap that fills the room like a quiet metronome. Technicians monitor the welds closely, ensuring each one is strong enough to carry current without adding resistance. If a weld looks weak or uneven, the cell is pulled from the line for rework. Once connected, the cells are gently bundled together and secured with heat-resistant tape or insulated wraps to prevent movement. By the end of this stage, loose individual cells have been transformed into solid, unified battery packs. They're compact, sturdy, and already starting to resemble the beating heart of a power bank, ready to be paired with the electronics that will make them smart, safe, and reliable. With the battery packs ready, the focus shifts to the brains of the operation, the circuit boards that will manage every bit of energy flowing in and out. These boards aren't just flat pieces of green plastic. They're the power bank's command center, controlling charging speeds, protecting against overloads, and communicating with your devices. Production starts with bare PCB panels sliding into high-speed assembly lines, where robotic arms place microscopic components with a speed and accuracy that's almost hypnotic. Tiny resistors, capacitors, microchips, and USB port connectors are positioned in place so quickly, it's hard to believe there's no blur in the movement. Once the placement is complete, Boys crane decay imposed and space gains. The boards pass through reflow ovens, long, tunnel-like machines that use precise heat to melt the solder and permanently fuse each component to the board. The air here is warm and faintly metallic, and the boards emerge with a glossy sheen where the solder joints catch the light. From there, each board undergoes a round of inspection. Some factories use automated optical scanners that zoom in on every connection, looking for the tiniest imperfection, while others rely on skilled technicians with magnifying lamps and a trained eye. If a board doesn't pass inspection, it's sent back for immediate repair, rather than risk it in the final product. By the time this stage is done, the raw PCB has become a fully functional control unit, capable of balancing battery cells, regulating voltage, and ensuring that the power bank won't just work. It'll work safely and efficiently every time you plug it in. Now the muscle and the brain come together. The finished battery packs are brought to the assembly stations where they're paired with the freshly built circuit boards. Technicians begin by carefully aligning the battery terminals with the designated connection points on the PCB, securing them with either soldered wires or flat bus bars depending on the design. The joins need to be solid enough to handle constant charging and discharging without loosening over time. Safety components are added at this stage: tiny thermal sensors that monitor heat, miniature fuses that cut power in case of a short, and protective chips that prevent overcharging or deep discharging. These are the unseen guardians that keep a power bank from overheating in your pocket or swelling up after months of use. Once all connections are made, the entire assembly is wrapped in a protective layer. Some models use heat shrink tubing that tightens snugly around the pack when exposed to hot air, while others fit the battery and board into a slim inner housing. Each unit is inspected for clean wiring and secure fits. Wires are neatly routed, tape is pressed firmly in place, and nothing is allowed to rattle or shift. The completed core feels solid in the hand, with no loose movement, a compact, self-contained power unit that's ready for its outer shell. At this point, it's already functional, capable of charging your phone, but the casing, ports, and finishing touches will turn it from a working prototype into the sleek device you toss in your bag every day. With the inner workings complete, attention turns to the casing. The first thing you see when you pick up a power bank. Depending on the model, these shells are made from high-strength plastic, brushed aluminum, or even a combination of both for style and durability. In one part of the factory, injection molding machines pump molten plastic into precision steel molds, creating perfectly shaped halves of the outer shell. The freshly molded pieces drop onto conveyors still warm to the touch, edges clean and smooth. For metal cases, sheets are stamped, bent, and anodized to achieve that sleek, scratch-resistant finish. Before the electronics go inside, the casing is prepared with all the necessary components. USB ports are slotted into place, LED indicators are fitted, and buttons are mounted so they align perfectly with the underlying switches on the circuit board. Each piece clicks in with a satisfying snap, and workers double-check alignment so that every port lines up cleanly. The battery core assembly is then placed inside, carefully seated, so that no wires are pinched and nothing shifts. Depending on the design, the casing halves are fastened with tiny screws, ultrasonic welding, or precision fit clips. Once sealed, the unit feels solid and ready for real-world use. No creaks, no gaps, just a seamless finish. At this point, the power bank has the look and feel of the final product, but it's not ready to leave the factory floor just yet. Before it can earn a spot in your backpack or desk drawer, it has to prove itself through a series of demanding tests. Testing is where every power bank has to prove it's not just good-looking, but dependable under pressure. The first checks focus on performance. Units are connected to charging stations and run through controlled charge and discharge cycles to verify that their capacity matches the specifications. Machines simulate real-world use, drawing power as if they were charging a phone or tablet, while sensors log every fluctuation in voltage and current. If a unit charges too slowly, drains too quickly, or fails to deliver stable output, it's pulled from the line for investigation. Next come the safety trials. Overcharge tests push the battery beyond normal limits to make sure built-in protection kicks in. Short-circuit tests deliberately create a fault to confirm that the safety fuses respond instantly. There are also thermal tests, where the power bank is run at high load in a heated chamber to ensure it doesn't overheat. Then, there's durability. Some units are dropped from set heights onto hard surfaces to test their resilience. Others are subjected to vibration platforms to mimic the bumps and shakes of daily life in a bag or car. Throughout it all, technicians watch for cracks in the casing, loose components, or performance dips. By the end of this stage, only power banks that meet every standard, electrical, safety, and physical, are cleared for the final step. The rest, no matter how small the flaw, are either reworked or scrapped. In this business, reliability isn't a luxury, it's the bare minimum. Once a power bank has passed every test, it's finally ready for its finishing touches. The freshly approved units move to the packaging area, where the process is as much about presentation as it is about protection. First, each device gets a final wipe down to remove any dust or fingerprints, ensuring it looks pristine right out of the box. Labels are applied with the model name, capacity, certifications, and safety warnings, all printed with sharp, clean text that reinforces the brand's quality. From there, the power bank is paired with its accessories, usually a charging cable, sometimes an instruction manual, and occasionally a carrying pouch. These are neatly arranged inside custom-fitted inserts or molded trays that keep everything in place during transport. The retail box itself might be a simple cardboard sleeve or a premium, full-color printed package with glossy finishes and product images designed to catch your eye on a store shelf. Once boxed, units are sealed, either with tamper-evident stickers or shrink wrap, before being packed into larger cartons for bulk shipping. Each carton is labeled with barcodes and batch numbers, so every shipment can be tracked from the warehouse to the retailer. At this point, the power banks are officially production ready. They're stacked onto pallets, shrink-wrapped for stability, and moved into storage or loaded directly onto trucks for distribution. Whether they're headed to a small local shop or a massive online retailer's fulfillment center, every unit has the same purpose: to be ready when someone's battery hits 2% and they need a lifeline. From the packaging floor, the journey continues into storage, a step that's more important than it sounds. Freshly made power banks are moved into climate-controlled warehouses, where temperature and humidity are carefully maintained. Lithium batteries don't like extremes, so the environment is kept cool and stable to preserve both safety and performance. Rows of shelves stretch out like a library of energy, each pallet stacked neatly with cartons marked by model, color, and batch number. Inventory teams log every incoming pallet into a tracking system, so at any moment, the factory can see exactly where a particular production run is sitting. When orders come in, whether it's for a single retail store or a shipment to another continent, the logistics team steps in. Forklifts maneuver between aisles, picking pallets and moving them to the loading docks. For domestic deliveries, trucks take the goods directly to distributors or retailers. For international orders, the power banks are packed into shipping containers, often cushioned with extra protective layers for the long journey. Even in this final stage, timing is crucial. Lithium-ion products have strict transport regulations, so shipments are coordinated to meet both safety standards and customer deadlines. From the moment they leave the dock, these power banks might travel by road, air, or sea, but the mission is the same: to arrive in perfect condition, ready to deliver that emergency boost of power to someone, somewhere, who needs it most. And that's how something that fits in your pocket goes through a process worthy of a full-scale industrial operation. From the careful selection of battery cells to the precision welding, the microscopic accuracy of circuit board assembly, the tough rounds of safety testing, and the clean finish of packaging, every stage is about reliability. A power bank isn't just a convenience. For many people, it's the difference between staying connected and going dark at the worst possible moment. The next time you plug one in, you'll know the journey it's taken. From raw materials sourced with care, to a production line where sparks fly, machines hum, and workers check every detail, to the moment it lands in your hand, looking effortless and ready for work. It's engineering, safety, and design working together in a neat little rectangle. If you found the process as fascinating as I did, drop a comment on what other tech you'd like to see made from the inside out. Hit the like button if you learned something new, and share this with someone who can't live without their power bank, because behind that simple gadget is a story worth telling.